It is now time for us to do the proofs of the trig derivatives. And I know that you've heard me say this before about we are experiencing this together. I have to say proofs are not my favorite thing to do. They're kind of fun, like a puzzle, but I'd rather do something else. But I consider it sort of like medicine, that it makes you stronger, better, okay, for having taken it, for doing it, and it gives you another chance to practice your trig. These particular sum and difference rules that we have here, as my Latin teacher would want me to say, formulae. Okay, most books are saying formulas, so we can do this, whether you call them formulae or rules, but you'll remember these trig sum and difference rules. And so if you have sine of x plus y, and then see the pattern between these two, for sine of a sum and difference, it goes sine, cosine, cosine, sine. See? Sine, cosine, cosine, sine. And the SIGN in the middle matches. Okay? So that this SIGN matches this one for sine. If it's plus originally, it's plus in the middle. It's minus. Cosine, though, see their pattern? It goes cosine, cosine, sine, sine, right? They're both like that. But just sort of like the derivative of cosine has the negative thrown in the front of it, this one changes. So if it was plus, it's minus. If it's minus, it's plus. And the reason I'm showing that to you is we're going to make extensive use of these in these proofs. And so I wanted you to see them. And I'm laughing. I know I shouldn't be laughing, but I actually think this is fun. I hope you kind of find it fun, at least tolerable. We'll be coming back to these quite a bit. All right. So, and I teach trig too, and I have to admit that in trig class, I don't know that they're really helpful, but they are very helpful here. So here we go. So the first thing we're going to try to prove is that the derivative with respect to x of sine is actually cosine, right? That's our goal. Now, here we go. So if f of x is equal to sine, and we want f prime, and remember it's a limit as h goes to 0 of f of x plus h minus f of x over h. Okay, remember that one? All right, then here we go. So for our f prime, what we would have is the limit as h goes to 0 sine of x plus h minus the original function all over h. All right, now see this part right there? So that is the sine of a sum, and we're going to use that formula over here with the sine of a sum, and we're going to expand it so it would go sine, cosine, cosine, sine, where it's sine of the first, cosine of the second, cosine of the first, sine of the second. Here we go. So we would have the limit as h goes to 0, and we would have sine, cosine, cosine, sine, minus the original function, all over h. All right, so this part is just the expansion of the sum. All right, now what we're going to do next is some judicious rearranging and grouping. I've sometimes wondered, the very first person who figured this out, how long they looked at it before they decided they found, oh my goodness, if I do this, I can get this straightened out. So we are going to take this term right here and this one, and we're going to combine them, And that would give us sine of x cosine h minus sine of x all over h. Then that would leave us plus cosine x sine of h over h. So we've, in effect, put these two here, and this one comes over here, and we've split them up with a common denominator. Okay? Then somebody went, oh my goodness, out of that first fraction, I can factor out a sine. So I'm going to factor that out, and that would leave me cosine of h minus 1 over h plus cosine of x sine of h over h. So this would be the limit, if you split it all up all the way down, the limit as h goes to 0 of sine of x times the limit as h goes to 0 of cosine h minus 1 over h plus the limit as h goes to 0 of cosine x times the limit as h goes to 0 of sine h over h. Okay? Now, starting from the left and working our way across. This limit as h goes to 0 of sine of x, there's nothing to put h going to 0 into, so this is just sine of x. But this is 0. Remember we learned that? And then the limit as h goes to 0 of cosine x is just cosine x. And this goes to 1. So 0 times anything is 0, and this turns out to be cosine x. So the derivative of sine is cosine. All right, doing okay? All right, here we go. So now we're trying to decide, is the derivative with respect to x of cosine x actually the negative of the sine of x? And we're going to be doing really some very similar kinds of expansion and rearranging. Okay, so remember we've got f of x, in this case, is cosine of x. And the fastest way to memorize something is to write it down. So here's my formal definition of the derivative, and I'm going to fill in my pieces. So here's the limit as h goes to 0. The denominator is always h. This last term in the top is always the original function. This is always the original function with x plus h put in place of x. Okay, now see right here? Here's that sum or difference, but this time it's cosine. And remember, cosine goes somewhere way up here. Cosine goes cosine, cosine, sine, sine, and the sign in the middle is the opposite of what you start with. So this turns out to be, so this is our cosine. So what you get is the limit as h goes to 0 of cosine, cosine, sine, sine, and if it was a plus, it's now a minus the original function. So this was the expansion. Okay? Right. Now we're going to do some creative grouping. And we are going to group this one and this one. And hopefully it's okay with you. I'm going to actually, since you've seen something like it right just a minute ago at the top, we're going to factor as we go. So have cosine x times cosine of h minus 1 over h minus sine of x sine of h over h. And then I'm going to show all my little bits and pieces. So it's the limit as h goes to 0 of cosine x times the limit as h goes to 0 of cosine h minus 1 over h minus the limit as h goes to 0 of sine x times the limit as h goes to 0 of sine h over h. And this is 0, and 0 times anything is 0, minus the limit of sine x as h goes to 0 is sine x because there's no h. And this goes to 1, so this turns out to be negative sine x. So we can say that the derivative with respect to x of cosine x is negative sine x. Now, some teachers at this point will let you do something like, if you're trying to show that the derivative with respect to x of tangent x is, or I don't know, let's do secant or tangent. Yeah. I'm sorry, I got distracted. Y'all never do that, do you? I get distracted. All right. So sometimes they'll let you say, okay, I just proved sine and cosine. So I would be going, this is sine x over cosine x, and I would use the quotient rule. But if they tell you that you have to use this formal definition, the limit definition, then you can't do that. Okay? So here we go. So f of x is tangent x. This one's quite a bit more complicated. All right. So hang on. You can do this. I keep saying this. You're in calculus. You can do this. All right. Now, here we go. So f prime of x. You're probably bored with this, but it'll help you to memorize it. So it's the limit as h goes to 0 of f of x plus h minus f of x over h. So my f prime would be the limit as h goes to 0 of tangent x plus h minus tangent x over h. And it does look like we're going to go back and pull that part about the sine and cosine. So this is sine of x plus h over cosine of x plus h minus sine of x over cosine of x over h. And does this look like a complex fraction to you? And the answer should be yes. So we are going to multiply top and bottom by the least common denominator. So this would be cosine x plus h cosine x over cosine x plus h cosine x. So we're multiplying by a version of 1. And we are going to cancel where we can. So when you multiply this by the first term, the cosine x plus h's are going to cancel. And you will have sine of x plus h times cosine of x minus, and when you multiply here, the cosine x's cancel, and you have sine of x times cosine of x plus h all over h times cosine of x plus h cosine of x. Okay? Now, what we're going to do is sort of reverse the sum and difference rules that we had. So, can you see that this is sine, cosine, and if you reversed these two, it'd be cosine sine. Let me write that down. So it's sine of the first, cosine of the second, minus, because it goes sine, cosine, cosine of the first, sine of the second. So it goes sine, cosine, cosine, sine over h. So if it goes sine, cosine, cosine, sine, then this is the sine sum and difference. There's a lot of signs in here, right? There's sine, and then there's sine. Okay. So this is the sine difference formula. And remember, the plus or minus signs match for the sine sum and difference rules. All right. So if this is a minus, it was minus to start. Okay. So this is the sine. And the first term is x plus h minus the second is just an x. My n didn't show up. Excuse me. Over h cosine x plus h cosine x. Limit. Remember, if you leave limit off, they'll count it wrong after all this hard work. All right, so I can clean the numerator a little bit. X plus h minus x is sine of h over h cosine x plus h cosine x. So this is the limit as h goes to 0 of sine h over h times the limit as h goes to 0 of 1 over cosine x plus h cosine x. This is 1, so it's 1 times, and you'd have 1 over cosine x plus 0 cosine x. So it's cosine x times cosine x. So it's 1 over cosine squared x, which is secant squared x. So the derivative with respect to x of tangent x is secant squared x. We're about halfway. Okay. Now let's do cotangent. So I'm going to try to prove that the derivative of cotangent is cosecant squared with a negative. Because remember, everything that starts with a C has a negative there. And since we've been doing this a while, I'm going to leave out that, but I'm going to say it. Okay, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. All right, so if my f of x is cotangent x, then f prime of x would be the limit as h goes to 0. And you would have cotangent x here and cotangent x plus h here all over h, right? And we are going to use kind of the same principle up here where we changed it to sines and cosines. So we would have the limit as h goes to 0. And cotangent is cosine over sine minus cosine of x over sine of x over h. And once again, we have a complex fraction limit. So we are going to multiply by the least common denominator. See why I didn't, well, if you remember back to the explanation of how to take a limit with a complex fraction, and I said, yeah, this gets really complicated pretty quickly. So it's best to do this with what I call technique 1 versus 2, is to do the multiply by the least common denominator instead of trying to make the fractions squeeze together. All right, I think you're beginning, if you don't already, see why I really wanted you to learn that. Okay, so I multiply this times this first term, and the sine of x plus h is cancel. So you have cosine of x plus h times sine of x minus. And when you multiply by the second term, the sine x is canceled, so you have cosine x sine of x plus h left over h times sine of x plus h sine of x. Now you should kind of be going, okay, I know where this is going, because you kind of seen how they go in pairs. All right, now here you go. So we've got this cosine x plus h sine of x cosine x sine of x plus h. And if you kind of look at this and, I don't know, kind of turn your head, squint your eyes a little bit, okay, then what you can do is to sit here and say, okay, I am going to factor out a negative. And that will leave me, and I'm going to switch these around. So I'm going to switch these two around at the same time that I'm factoring out a negative. So I'd have sine of x plus h cosine x. Okay, now this, I factored out this negative so it became positive, but this was positive, so it's going to become negative. And you'd have cosine x plus h sine x. Now, why did I think I wanted to factor out that negative? Well, I'm going to be honest with you. Okay, the reason you think you want to factor out that negative is because you know it's supposed to have a negative when you get done. So you're thinking this is a good place to find it, right? So, and that's why. I don't know that it would occur to you normally to do that unless you knew the end result, the goal, and then you would think, oh, I should factor out that negative, right? But if you're looking at like, who does that? Somebody long gone who saw that and came up with it the first time, and we just use that as our nice way to remember how to get this done. So then we would have over this h of sine x plus h sine x. I've actually had students who took a test over this, and usually I ask them one proof, and they'll get so hung up they forget to keep writing down the denominator, and the denominator goes away. So you have to keep writing this even though we're focusing on the numerator, right? So we have this minus. Now look up here at this pattern. So this pattern goes sine, cosine, cosine, sine, right? So this is a sine, S-I-N-E, a sine pattern, right? Plus or minus. And so, and whatever this S-I-G-N is the same one we're going to have. So what we have going here is sine of x plus h minus x all over h sine of x plus h sine of x. All right. So then sine of x plus h minus x just becomes sine of h. over h sine x plus h sine of x. So I have negative sine h over h times the limit as h goes to 0 of 1 over sine x plus h sine x. So this is going to go to negative 1 because I had a negative. And this is going to be 1 over sine squared x because when you put 0 in here, it's just another sine x. So this is negative cosecant squared x. So the derivative with respect to x of cotangent x is negative cosecant squared x. You know, sometimes you just have to sit here and smile and kind of laugh and go, okay, because frowning at it doesn't make it go any faster. All right. You can do this. You knew that was coming. All right, here we go. Now I'm trying to prove the derivative with respect to x of secant x. Let's try that again. Secant x equals secant x tangent x. That's what I'm trying to prove. So my f is secant x. And the derivative, right, is the limit as h goes to 0 of f of x plus h minus f of x over h. So f prime is the limit as h goes to 0. Here's h. This is your original function, s-e-c-x. And this is x plus h. All right. So this is the limit as h goes to 0 of 1 over cosine x plus h and 1 over cosine of x over h. And it's another complex fraction. It's going to become our favorite technique. Multiply top and bottom by your common denominator. All right. So when you multiply these two out, the cosine x plus h's cancel, and you have cosine of x left minus. And when you multiply these two out, the cosine x's cancel, cosine x plus h all over h, cosine x plus h, cosine x. All right. Now, this one right here, this part right there, we're going to use the sum and difference formulas rules again, and this is cosine of a sum. So cosine goes cosine, cosine, sine, sine, and if this is a plus, it's going to be a minus in between because it switches, right? So it's going to be the limit as h goes to 0 of cosine x minus, and you've got cosine, cosine, sine, sine. And if it was plus, this is a minus. Over h cosine x plus h cosine x. All right. Now what we're going to do is take this one and this one right here and work those two together and factor out what's in common. So it's the limit. Each one has their own little kind of trick, as it were. twist, something unusual that you sort of have to know is coming in order to reproduce it again. So this one is to group these and factor out cosine x. And you would have 1 minus cosine h. All right. Now, this negative times this negative is actually a plus. So you would have plus sine x sine of h all over this. And you can probably see this even better now, what's coming. All right. So we have the limit as h goes to 0 of cosine x times the limit as h goes to 0 of 1 minus cosine h over this common denominator. Okay, plus the limit as h goes to 0 of sine x sine h over h cosine of x plus h cosine of x. All right, now what this is going to turn out to be, right, is I don't know if it won't be more plain to you if we leave this one out and kind of put all this like this. Okay, so what you're going to end up with, no, let's leave that back. Take it back. I don't think that's going to necessarily help you too much. All right, so what this is going to do is go to 0 plus, and this part right here is going to go to 1, right? This is going to drive to 0. This is going to go to 1, right? So what you have is sine of x over cosine x squared. So you can think of this as sine x cosine x times 1 over cosine x, right? So this turns out to be tangent, and this is secant. So the derivative with respect to x of secant x is normally written as secant x tangent x. They just switch these around. Okay, now the next one is cosecant. And this is what we're trying to prove. Right. So what you might want to do is just stop here, right? And stop the video and see if you can work it out. It's going to be sort of like this pattern right here. Just test yourself, all right? And then come back in and then catch back up and see if we kind of had the same attack, right? And so hopefully you're back. And you would have minus cosecant x here and cosecant x plus h. And here's your h. And this is the limit as h goes to 0 of 1 over sine x plus h minus 1 over sine of x over h. And here we go again. Beautiful complex fraction. So we're going to multiply by our least common denominator and cancel where we can. So this times this first term. I mean, you have to give them credit. This is actually kind of cool. I don't know that it's cool enough to raise the hair on your arms and, make you go amazing, but it's kind of cool. All right, so the sine of x plus h cancel, and you have sine of x minus, and sine of x times sine of x cancels. Sine of x plus h over h, sine of x plus h, sine of x. We're nearing the end, so I'm getting kind of silly. Sorry about that. All right, so here we go. So we can do this. We're almost done. All right, so see this part right here? We have the sine of a sum, so we're going to expand that. So we have sine of x minus, and the sine of a sum goes sine, cosine, cosine, sine. So sine, cosine, cosine, sine. This is how I have my trig students learn it, where they kind of sing along. Sine, cosine, cosine, sine. All right. And then the sign in the middle is a match because it's sine. Okay. S-I-N-E, sine. You got to find your laughter here somewhere. Okay. All right. So then we're going to do some judicious rearranging and kind of grouping. And remember, this minus is going to distribute across here. So when I do this judicious rearranging, it's going to be the limit as h goes to 0 of sine x times 1 minus cosine h. Okay, which is these first two terms, minus cosine x sine h over all of this. Okay, so when you get this kind of cleaned up, you have the limit h goes to 0 of sine of x 1 minus cosine h over h sine of x plus h sine of x minus the limit as h goes to 0 of cosine x sine of h over h sine of x plus h sine of x. All right. So again, this part is going to drive this to 0. And this part is 1. So you've got 0 minus cosine x over sine x squared. So you've got cosine x over sine x times 1 over sine x. We're almost done, which is, oh, don't forget our minus. There's a minus right there. Equals minus, okay, and this is cotangent, cosecant. So the derivative with respect to x of cosecant x is minus cosecant x cotangent is the way you most often see it. And there you go. So I think you can kind of see why I wanted to put all the proofs together instead of in the body of the applications of the derivatives, just so that we don't get hung up with all this. Anyway, I hope that you kind of enjoyed this. And that actually, you should kind of enjoy it. I'm laughing probably because it's late at night and I get kind of silly. But at any rate, proofs really are good. They're good for us to do. They're good for us to follow. It's good to find out that these things don't just fall out of thin air, that there actually is some substance. So it's good for us. Don't forget to like the program, like the video, subscribe. There's a link down below that takes you back to the trig derivatives, so that if you decided to look at this on the first one, you can just get back to any one of the ones that you want to get back to. And good luck with your trig derivatives. Work hard, memorize these things. You have to memorize them. They usually, I haven't seen anybody ever let you bring these in on a note card. I guess there's a first time for me to see that, but don't depend on it. So memorize these end results about what the derivatives are. And the next, after the trig derivatives, so keep moving on to more kinds. So, and I will see you next time.